We have a little problem here that makes use of a few things in calculus. A particle moves along a line so that any time t is greater than or equal to 0, its velocity is given by v of t equals t over 1 plus t squared. At t equals 0, the position of the particle is 5. Determine the position of the particle at t equals 3. And so what you essentially have is distance covered. So distance equals the integral of the velocity dt. And so we're going to try to find the position at t equals 3. And we're given a starting point. And so we see at t equals 0, the position is 5. And so what we're going to have here is our starting position 5. Our position is going to be 5 plus the integral from 0 to 3 at t equals 3, from 0 to 3, of v of t, which is t over 1 plus t squared dt. Okay, v of t dt. What we're going to do to integrate this, it's looks like a little bit of a complicated thing here, but I think that with the U substitution we can cancel out this t in the numerator. And so I'm going to come over here to the right and say let u equal 1 plus t squared. So du is equal to 2t dt, and dt, if we divide by 2t, dt is equal to du over 2t. So now we can come back here and rewrite this as 5 plus, and until I reestablish the limits, I'm not going to put them right here, but we have t, and we're replacing this 1 plus t squared with u, and then we're replacing this dt with du over 2t. So I'm going to put du over 2t, and then t over t will cancel here, and so we're left with 5 plus 1 over u du. And let me just fix that a little bit. I'll put 1/2 integral of 1 over u du. Well, the integral of a variable to the -1 power is the natural logarithm, so I'll come over here, we'll say equals 5 plus 1/2 ln of absolute value of u, and then we're going to reintroduce the limits here. We replace this u back again, so we have 5 plus 1/2 ln of absolute value of 1 plus t squared, and we put the limits back here from 0 to 3. Coming down here, we have 5 plus, if we have 1/2, if we replace this t with 3, we have t squared, which is 9, plus 1 is 10. So we have ln 10, absolute value of 10, which is 10, and we're going to subtract 1/2 ln of 1. If we plug in 0 for t, we'll have ln 1. Well, ln 1 is going to be 0, so our final answer is going to be 5 plus 1/2 ln that's going to be approximately equal to 6.15, I believe. But anyway, I like this problem because it makes use of a few things we've been going over pretty much all year in calculus. Good luck, and thanks for viewing.